we have finished understanding how A type works. Yeah, we finished understanding A type works. Well, if we have pi 1 and pi 2 and pi 3, and their perpendicular vectors are n1, n2, and n3 respectively, you just have to show that n1 can be written as s n2 plus t n3. That's all you had to do. Okay, so from this, we are going to the consistent systems of equations. Okay, in that specific part, I am going to start with the most important one, which is the planes. Okay, the planes intersecting at a single line. Okay, the planes intersecting at a single line. That's what I'm going to teach first. Okay, so let's say we have the third plane coming like this, the third plane that comes like this. Okay, so they are intersecting at a single line. Yeah, they are intersecting at a single line, as you can see here. So if this is pi 1 and this is pi 2, and let's say this is pi 3, what you have to prove here is, if they are intersecting at a single line, you have to show that pi 1 can be given as s pi 2 plus t pi 3. You're going one step ahead. Okay, you're going one step ahead. Where you have to show from, you have to show that the perpendiculars, you can show that the perpendiculars are in this specific format, and then you can come to the plane format. Okay, so how can we do this? Let's do an example. So let's say pi 1. Okay, now in this question, okay, now in this question, you have to prove, well, these are not parallel to each other, right? How can we show that? Well, n1 can be given as 2, 3, and minus 3. n2 can be given as 5, 7, 2, and n3 can be given as 7, 10, and minus 1. Okay, so here we can clearly see n1 is not parallel to n2 and not parallel to n3. Okay, so here that we can clearly see that. Now let's take this. Well, I can see a pattern here that pi 3 is equals to pi 1 plus pi 2. Okay, I can see that pattern clearly here. How do I see that pattern? Well, first let's start with n1. Yeah, n1 is given as 2, 3 minus 3. So I just have to show that n1 is equals to s n2 plus t n3. But what I'm choosing is, I'm going to choose n3 as the subject. Okay, n3 equals to s n1 plus t n2. Okay, so n3 is given as 2, 3, sorry, 7, 10, minus 1. And n1, Sn1 can be written as 2s, 3s, minus 3s plus 5t, 7t, 2t. Perfect. Now the first equation is 7 is equals to 2s plus 5t. 10 is equals to 3s plus 7t. And minus 1 is equals to minus 3s plus 2t. So this is the first equation. This is the second equation. And this is the third equation. Okay. So I'm going to use second and third equation. If I add the second and third equation, I will get what? 9 equals to 90. So t equals to 1. So if I substitute t equals to 1 in the second equation, okay, t equals to 1 in second equation, that will give me 10 is equals to 3s plus 7. So s is equals to 1. How can I verify whether these values apply for three equations? Well, I have to verify from the first equation. First equation says 2s plus 5t, so that is equals to 7 actually. So this verifies. So I can write down these three equations such that n3 equals to, okay, uh, n1 plus n2. Okay, so they are actually intersecting like this. But this is not what we wanted to find. We wanted to find whether they intersect at a single line. That's what we wanted to find. So here, okay, let's check for pi 1, pi 2, and pi 3. Okay, let's see what is pi 1 plus pi 2 equals to. Pi 1 plus pi 2 is equal to 7x plus 10y minus z equals to 7. Surprise, surprise, that is equal to pi 3. That is given as pi 3. Okay, so the thing is, pi 3 can be given as phi 1 plus phi 2, which means they intersect at a single line. They are intersecting like this, where this is a single line. Okay, so this is how you have to prove whether they have a solution. Okay, so here we can clearly see they do have infinite number of solutions. Why? They're intersecting at a line, and a line has infinite number of points. So we have to find this line. Yeah, we have to find this line. That's the idea here. How can we find the line in which these three planes intersect? Simple. You just have to apply your knowledge from how to find the intersecting line of two planes. Why? If you find the line of intersection of phi 1 and phi 2, okay, if you can find the intersection of phi 1 and phi 2, that means phi 1 and phi 2 are intersecting at a specific line L. And phi 2 and phi 3 will also intersect at that specific line. Why? All these three planes are intersecting at the specific line. Okay, so that's what we have to do next. Okay, since we have found out that they intersect at a single line, now we can find the single line or the solution, the infinite number of solutions in which they intersect. Okay, so let's only take phi 1 and phi 2, because phi 1 and phi 2 have simpler numbers. Okay, phi 1 is given as 2x plus 3y minus 3z equals to 2, and phi 2 is given as 5x plus 7y plus 2z is equals to 5. Okay, so I'm going to use only those two equations. Okay, so wait, I'll erase the other things. These things are not needed. Okay, so this is 1 and this is 2. Let v equals to lambda. So here I can say x is 2x plus 3y is equals to 2 plus 3z, 5x plus 7y equals to 5 minus 2z. Okay, so this can be rewritten as 10x plus 15y equals to 10 plus 15z, and this can be written as 10x plus 14y equals to 10 minus 4z. Okay, so if I subtract this equation from this, I will get y equals to 10 cancel, so it will get 19z. Okay, and if I substitute this in one of these equations, I will get 2x plus 57z equals to 2 plus 3z. So 2x is equal to 2 minus 54z. So x is equal to 1 minus 27z. So what's the equation of the line? Well, the parametric way of writing the line L can be x equals to 1 minus 27 lambda. Okay, I didn't write it as lambda. Yeah, that's a mistake. Okay. This should be lambda because we let z as lambda, parametric value lambda. So we have to put it as lambda, 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 lambda. Y equals to 19 lambda. Z equals to lambda. How can I write the vector equation? Pretty simple. L can be given as R equals to, we have to find a point on the line. It's not very hard. Just simply substitute 0 for lambda. So that will give you 1, 0, 0 plus 1 minus 27. Sorry, not 1 minus 27, minus 27, 19, 1 into lambda. Okay. So phi 1, phi 2, and phi 3 intersect at this specific line. Okay. So yeah.
Thanks for watching the 44th video in our lecture series. If you found this explanation of three things intersecting at a single line helpful, don't forget to like, share, and subscribe for more tutorials. Hit the bell icon to stay updated with our latest videos and check out the full playlist of master lectures. Follow us on Instagram and see you in the next video. Until then, keep learning and stay curious. Bye bye.